paper 44. Let's take a look at question number 1. We have a random sample of 12 observations of a normal random variable is taken. The result give unbiased estimates of the population's mean and variance as the following here, 10.24 and 0.52 respectively. Test at 10% significant level the null hypothesis that the population's mean is 10.6 against the alternative hypothesis that the population mean is less than 10.6. So over here, we can just write down the null hypothesis and the alternative hypothesis. We have the population's mean is 10.6. This one is less than 10.6. Okay, so we will be having mean. They give you the bar x is 10.24. And the unbiased estimations of the population variance is 0.50. Okay. So now our test will be the alpha is equals to the 10%. Then the degree of freedom is 12 minus 1 is equal to 11. Okay, this is the degree of freedom. Then your critical value, this will be a t-test because the sample size is small, the n is 12 only. So the critical value will be the, go and find the t value. It will be degree of freedom 11. The confidence level is 90%. So from the formula table, you can get this one as the negative 1.363 because this one is left tail. It's a left tail test. Okay, so now we will be having our test statistics as t equals to the bar x minus the population mean divided by the unbiased estimations of the population variance, which is a 0.52 divided by 12. Press a calculator, then you will get this as negative 1.729. That is your test statistics. You compare the test statistics, you can negative 1.729 modulus it, and you modulus the critical value so that you compare only the positive value. You can see that the test statistic is greater than the critical value. Therefore, you will reject H now. I mean, this is greater than this. Reject H now. So, conclusion. There is sufficient evidence to support that the population mean is less than 0.6. Okay, done. So this will be the answer for the question number 1. That's all. So now we move on to the question number 2. Of sound produced by a particular type of machine was measured for a random sample of 11 such machines. The result in suitable units are shown below. So these are the data that is given over here. Use a Wilcoxon siren test to test whether the average sound level produced by this type of machine is more than 8.0. Use a 5% significant level. Okay. So first of all, we can just write down the null hypothesis and the alternative hypothesis. So since it's Wilcoxon, we will use the median. just say that the population median M is equal to 8.00 versus the alternative hypothesis, the median will be more than 8.00. This is stated in the questions. So we need to find the difference. That means we need to find the x. This is the x. You minus the 8.00, and you are going to rank them, give a name of P and Q. So if you minus the 8.00 over here, you get negative 0.34, positive 0.48, positive 0.21, negative 0.02, positive 0.01, negative 0.3, positive 0.25, 0.11, 0.03, 0.16, and negative 0.08. So you use a rank 1, and then 2, and then 3, and then 4, and then 5, 6, 11, sorry, not 6, 7. 7 is here. 8, 9, 10, and 11 is over here. Okay, so this is the rank that we have. So the P1 we sum all together, you get 40. Then the Q you sum all together, you get 24. So the test statistics is actually test statistics is actually the minimum between P and Q. Minimum between 42 and 24. Very obvious is 24. That is your test statistics. So now we need to find the critical value. Our alpha given the question is that the significant level is 5%. So alpha is 0.05. Okay, so your critical value or the tabular value from the table, you can get 13. You just need to mention that you get this one from the table. So you compare the test statistics with the critical value. So the test statistics is greater than the critical value. Here you should do not reject H now. Do not reject H now. So your conclusion right now, just state that that is insufficient. Evidence to support that the average sound level is more than 8.00. Okay, so this is the answer for question number 2A. Now move on. 2B. Give a reason why the Wilcoxon sign rank test may be more appropriate than the t-test. So we all should know that the t-test, the criteria is that the underlying distribution must be normal. Okay, normal distributions. So is the question mentions that the data collected from a normal distributions? Actually, the question did not mention at all. Okay, you can see the question, they did not mention anything about normal distributions. So this is the reason. Okay, so you just say that the underlying distribution is not known to be distributed. So this is the usual answer. Okay. Now we move on to the number 3. Top selling electrical goods has a team of 3 salespeople, Avril, Ben, and Charlie. The manager wishes to investigate whether the salespeople are equally successful at selling particular types of items. The following table gives a record of random sample of 250 sales of laptops, cameras, and televisions, with the number sold of each of the by each of the 3 salespeople. Okay, so that's at 10% significant level whether there is an independence between the type of the item sold and the salesperson. Okay, so we will, this one obviously is a chi-square test, so we need to review again the table. I want to find the expected frequency. Okay, so what they give you here in the table, the value, okay, all the value here, they are called observed frequency. We are looking for the expected frequency. So the expected frequency, I will review again the table. Then how do you find the first value? Just take 75 multiply 95 divided by 250. So you get, just multiply it, you'll get 28.5. That is your expected value for the first item, okay, first column. Okay, then this one, it will be 110 multiply 95 divided by 250, then you will get 41.8. Okay, so you just follow this kind of formula or the pattern, you'll get the rest of it. So to save time, I have calculated them out earlier. I just give you the result that I have calculated. Okay, so this one is a 42.68. This one is a 25.52. This one is a 25.2, and the last one is a 15.08. Okay, so this will be the expected frequency. So now we can build the null hypothesis and the alternative hypothesis. So the null hypothesis is there is a item, type of item sold is independent. Okay, of sale people. Okay. Then versus the alternative hypothesis, the type of item sold is not independent of salespeople. Okay, so this is the hypothesis. Then we need to find the degree of freedom. For alpha is given as 10%. Our degree of freedom is the column, you have 3 column, 3 minus 1, you have 3 row, 3 minus 1. So you multiply them together, you get a 4. So your critical value will be the chi-square, degree of freedom 4. The confidence level is 90%. Okay. So you will, just from the table, you can get this one as a 7.778 from the table. Now we want to find the test statistics. So this one is a bit troublesome. So the test statistics is a chi-square. So the formula for chi-square is the sum of the OI minus the EI square divided by EI. Okay. So we just write like this so that to save our time to show them one by one. So I need to calculate the first one over here. So the first one over here, to calculate by right, you're supposed to take the 31 minus a 28.5 square divided by 28.5. Okay, but since I have shown the formula such a way, so there's no need for me to write this one out anymore. I just direct press from the calculator. So you will get this one as a 0.21930. And the second one, it will be the same thing. You will get 0.07751 plus the 0.01983 plus the 1.27869. Okay, and then plus the 0.12611 plus the 0.56655 and 0.74483 plus a 0.01060 and lastly 0.62907. So you need to show all the value individually. Okay, so you total them up, you will get this one as the 3.67. Okay, you'll get this one as 3.67. So you compare the test statistics compared to the critical value. You can see that this one is less than. Okay, not enough place. I need more space over here. So this one, it will be your test statistics is less than the critical value. Over here means you're supposed to be do not reject H now. So your conclusion, you just mentioned that is there is insufficient evidence to support that the type of item sold is not independent of salespeople. And that will be the answer for the question number 3, just like that. Okay, so this one erased. Okay, so this is how you get the answer. Now we move on to the number 4. We have a PDF over here. Continuous random variable x has a PDF given in the piecewise functions over here. We want to show that the k is equals to the 6/17. So in order to show that the k is a 6/17, we need to integrate from 0 until 2. The fx will give you a 1. That means the total area here from 0 to 2 is a 1, which means that integrate from 0 to 1, kx plus integrate from 1 until 2, kx squared dx will give you a 1. So you have a kx squared over 2 plus the kx cubed over 3 from 1 until 2. This one from 0 until 1 will give you the total of 1. So just substitute the value inside, you will get k over 2 minus a 0 plus the k over 3 minus the k over 3 will give you a 1. So at the end, you will get the 17/6k is equal to 1. Therefore, the k is equal to the 6/17 shown. That is the answer for the question number 4a. Move on, we have a b. Do we want to find the CDF of x? To find the CDF of x, we just, from the interval x to 1, you will get f1 is equal to integrate 0 until x of the kx. Your k already shown is 6/17. So when you integrate, you will get this as the 3/17x squared. Then for the interval 1, 2, your f2 actually it's not from 1 to 2. It's actually from 0 to 2. Okay. So it will be F1, you substitute 1 inside, then plus the 1 until x of the kx squared. So if you put 1 inside, you get 3 over 17. Then this one, you will get this one as a 2x cubed over 17 from 1 until x. And if you replace this inside, you will get this one as the 3 over 17 plus the 2x cubed over 17 minus the 2 over 17. So you will get this one as a 1 over 17 plus a 2 over 17 x cubed. That is your F2. Okay. So therefore, your CDF will be 0 for the x less than 0. This one for the x greater than 2. Then for x between 0 to 1, this one is okay. I mean this one is a 1 to 2. So you put F1 inside. F1 is a 3 over 17. This one is a 1 over 17 plus the 2 over 17 x cubed. That is a CDF of the functions f. Okay, so now we move on to the question C. We want to find the median value of x. To find the median value of x, that means we are looking for the Fm, which is equal to half. So you can see that if you put the 1 inside, you will get 3 over 17 is less than half. That means your median will not be here. Your median must be here, somewhere between 1 to 2. Okay. So we just need to replace the m inside to the second piecewise functions over here. So you will get this one as the 1 over 17 plus the 17m cubed is equal to the half. So you will get m cubed is equals to the 15 over 4. So your m is a cube root of the 15 over 4. You can give me the answer in decimal. 1.55. Three significant figure, not 1 decimal, sorry. 3 significant figure. That is the answer for the question number 4C. And move on. 4D, we want to find the E of 1 over x. So to find the E of 1 over x is actually you want to integrate from 0 to 2, 1 over x of the fx. So you need to separate them into 0 to 1 plus 1 to 2. Okay. So just now this one is supposed to be kx over x. It's actually k. Okay, so it will be, maybe we just write 1 over x multiply, this one is 6 over 17x. This one is 1 over x multiply kx squared. Kx squared, it will be 6 over 17 x squared. So you will be having integrate from 0 to 1, 6 over 17 plus the 1 to 2, 6 over 17x x. Just a normal integrations. So you will get this one as a 6 over 17x from 0 to 1 plus the 3 over 17 x squared from 1 until 2. Then you get 6 over 17 minus a 0 plus the 12 over 17 minus the 3 17. So you get 15 over 17. Done. This will be the answer for the question number 4D. And move on. We have question number 5. Has 3 identical coins, each of which is biased so that the probability of obtaining head when it's thrown is 1 over 3. The random variable x is the number of hits obtained when Eric throws 3 coins at the same time. Find the BGF of the GX. Okay. Find the BGF of the X. So over here, we actually need to know that this is X is representing the number of hits obtained. And from the descriptions over here, we actually know that this is actually a binomial distribution. The binomial of the n is 3 coin, and the chances to get hit is 1 over 3. So you will get Bx equal to 0. None of them is hit. That means it's 2 over 3 over 3. Then you will get 8 over 27. We want exact value, so usually we were not going to give the answer in decimal form. Bx equals to 1, Bx equals to 2, and the Bx equal to 3. Just like that. Bx equal to 3 is 1 over 3 power 3. It's quite easy. So to get this is a 3c1, 1, 3, and 3 square. So it's a 3c2, 1 over 3 square, 2 over 3. And you press a calculator, simplify them. You will get this one as a 12 over 27. This one is a 6 over 27. I leave the denominator all same. I don't plan to simplify them. So I want to make all the denominator have a same denominator, 27. So therefore, my BGF for the x, it will be equal to the 8 over 27 d power 0. D power 0 is a constant. Then 12 over 27 d power 1, 6 over 27 of d squared, and 1 over 27 of the d cube. Okay, done. This will be the answer. Now we move on to the D. Eric also have 2 fair-sided dice with a face number 1 to 6. A random variable y is a number of 6s obtained when Eric throws the 2 dice at the same time. It is given that the BGF for the y is like this. Okay, so it's given. We do not need to calculate it ourselves. So we just write down. Okay, given. Then the z is equal to the x plus y. So the gz is equal to the gx plus yt. Okay, but because here the sum of the number of hits. Okay, so this one it will be the gxt multiplied by the gyt. X and y are independent. X and y are independent. Okay, x and y are independent. Then you can make this become multiply. So this will be the same as the a long way to multiply. 6 over 27 plus the 12 over 27t plus the 6 over 27t squared plus the t cube. 1 over 27t cube. Multiply by 25 over 36 plus the 10 over 36t plus the 1 over 36t squared. Okay, so over here, usually we will factorize the denominator out. So take 27 multiply 36, you get 1 over 972. Then you have 8 plus 12t plus 6t squared plus t cubed. And 25 plus 10t plus t squared. That will be easier to multiply. So you just need to spend some time to multiply and expand and multiply, expand, and then simplify yourself. Then you should be able to get the answer. So over here, this one, actually, I can just leave it to you. I'll just give you the final answer that I have multiplied, expanded. So this will be a 200 plus the 380t plus the 278t square plus the 97t cube plus the 16t to the power of 4 and plus the t power 5. Okay, so this will be the answer for the question number 5B. Okay. So now we move on the C, and we want to use this GZ to find the mean and the variance of Z. Okay, so over here, let me just write down. I need to find the G prime Z. So it will be 1 over 972. So from here, if we differentiate 380, so have to take down. Okay, so 380 plus 556. Okay, so over here 380 plus the 556t plus the 91t square plus the 64t cube plus the 5t power 4. That is your first prime. And over here, I continue to differentiate for second time since I need to find the variance. So the second derivative will be 556 plus the 582 plus the 192t cube plus the 20t power 3. Okay. So now we want to find the EZ is the G prime 1. So it will be 380 plus the 556 plus the 291 plus the 64 plus 5. Press the calculator and you will get 1296 divided by 972, or you can simplify them become 3. That is your mean. And to find variance, you need to find the G double prime of 1 plus the G prime 1 minus the G 1 square. Okay, so this is the formula. So this one, it will be 380 plus, no, sorry. The G double prime is over here. 556 plus 582. Plus 192 plus 20 divided by 976 plus the mean minus the mean square. Okay. So just use the calculator. You can get this answer simplified directly. So you will get this one as a 17 over 18. Okay. So this will be the answer for the variance. And this is the answer for the question number 5C. Moving on, we'll be having question number 6. Yeah, question number 6. The question number 6, we have Lina and Mona are two statisticians who also write songs. The time of a song is number of minutes for which it lasts. For a random sample of 10 of a song, Lina calculate 95% confidence interval for the population mean time, minutes, and the confidence interval is given as the following. The times X minutes of Lina song are normally distributed. Okay, so find the sum of X and the sum of X squared for the 10 songs in Lina's sample. Okay, so we are having the N is a 10. And we are having the alpha is this is a 95%. So actually, confidence interval, we need to find the critical value first. This is a small sample. N is a 10, less than 30. So we should use T distributions. We should use t distributions. So the critical value is t. The degree of freedom is 9 because 10 minus 1. So your confidence level, it will be confidence interval, it will be this, the 97.5%. From the table, you will get this one as a 2.262. Okay. Then your Rx plus the T multiplied by the square root of the S square divided by N. The N is a 10. Is equal to the larger value, 3.13. Okay. And the X minus a T is equal to 2.95. So I call this one equation 1. I call this one equation 2. Well, I think I want to make my explanation here easier. I will not going to write t like this anymore. I will straight away write this one as the 2.262. That will be easier. You just make the X a little bit closer. Okay. So from here, we can take the equation 1 plus the equation 2. You will get 2 bar x is equals to the 6.08. That means your mean will be 3.04. The formula for mean is a bar x, sum of x divided by 10. So the sum of x will be 30.4. Okay, so you have found the sum of x. And in order to find the sum of x squared, just take the 1 minus the 2. So you will get 2 times of 2.262. Square root of s squared divided by 10 is equals to 0.16. So you will get, press a calculator. So you will get this one as the s squared is equal to 0.01583. 0689. So because I want to be more accurate, so I give more decimal places. Formula for the unbiased estimations of the population variance is 1/9. The sum of the x squared minus the sum of x squared divided by 10 is equal to the 0.01583, 0689. So again, just use a calculator, multiply here and there, you should be able to get the answer. The sum of x squared is actually 92.558. Or you can make it become 3 significant figure, which is a 92.6. 3 significant figure. Done. This will be the answer for the questions number 6A. Move on, we have a 6B. Now is Mona turn. Mona song is use a Y to represent, and they are normally distributed. We have the 8 sample of 8 of them, and they give you the sum of Y is a 24.8, and the sum of the Y square is a 76.98. Mona claims that the population mean time of a song is greater than the population mean time of Lina song, assuming that the two distributions have the same population variance. Has at 5% significant level whether there is evidence to support Mona's claim. So what is Mona's claim? Okay, I think we need to do hypothesis test, but before that, let us just find the bar Y for Mona. 24.8 divided by 8, get the 3.1. Okay, you get 3.1. Then unbiased estimations of the population variance of Mona will be 1/7, 76.98 minus the 24.8 square divided by 8. As the calculator, then you will get this one as a 0.0142. Okay. So we need to find the combined variance. The pool variance are pool variance. To be more precise, it's called pool variance. SB square. formula for SP square, it will be the just now the this one the SY. This is the SX. This is the SX. So we will take this value SX 0.01583. Okay, we make it maybe we make it become 5 significant figure will do. So I make it become, just take the 9 multiplied by 0.05831 plus the 7 multiplied by 0.014814286 divided by the 9 plus the 7. So press the calculator, you get 0.015155. Okay, that is a two variance. So with this information ready, we are ready to do the hypothesis test. We just say that because Mona claims that her song, the mean time is actually more than greater than the Lina. Okay, so we just say that the mu y is greater than the mu x. Okay, so over here is that the mu y is equal to the mu x. So this is the hypothesis, null hypothesis and the alternative hypothesis. Okay. So you can see that this is the two tail. This is the right tail. S. Your alpha is 5%. So your critical value, the degree of freedom, you define the degree of freedom is 10 plus 8 minus 2. So it's actually 9 plus 7. So right here is 16. So your critical value will be the degree of freedom 16. Your significant level is 95%. Your confidence level is 95%. Okay, so from the table, you can get this one as a 1.746. So now we will be using we need to find the test statistics right now. Test statistics, it will be the bar y minus the bar x minus the mean y minus the mean x divided by the square root of the SP square. 1 over the 10 plus 1 over the 8. So the bar y, just now the bar y is a 3.1, bar x is a 3.04 minus the 0 divided by square root of 0.15, 0.015. 155, 1 over 10 plus 1 over 8. Press the calculator, then you can get this as a 1.028. Okay, that is your test statistics. Now we just need to compare the test statistics compared to the critical value. Just now the critical value is 1.746. It's less than, that means the modulus T is less than the modulus of the critical value, 16 and 0.95. So over here, for this case, you shall not reject H now. And we can come to the conclusion. We just say that there is insufficient evidence to support that. Okay, to support Mona's claim will do. To support Mona's claim will do. Make it easier for us. Okay. So that means no solid evidence to say that Mona claim is true. So that's all. So this is the answer for the question number 6, and this will be also the last question for this paper. So I will stop the video here. I'll see you next time. Bye bye.